polynomials. So if you recall, monomials are things with just one term. Okay, and polynomials have many terms. So we're going to take one term and we're going to be multiplying them by many terms. So in order to do this, we need to take a quick little review of what our rules of exponents are. So first of all, we want to talk about adding exponents. When we multiply like bases, we add exponents. You only add the exponents if you're multiplying. A lot of students get confused when they combine like terms and try and add the exponents. You only add the exponents if there's multiplication between terms involved. Then you multiply exponents when you're taking a power of a power. Okay, if you're taking a power of a power, you're going to multiply exponents. And then the 0 exponent is always 1. If you have anything raised to the 0 power, it's always 1. Okay, so let's take a look at the distributive property. So the distributive property lets you multiply by a sum by multiplying each term separately. You've done this before. You've had a number written on the outside of maybe an expression, and you've taken that number and you've distributed it into each term. That represents the distributive property. Now remember, I'm going to talk a lot faster than you can write, so please feel free to pause the video to get everything written down. So how do we use the distributive property? Well, the first thing we do is we distribute the monomial, that one term on the outside, to each of the terms in the polynomial. Then we're going to multiply each pair of monomials. We're going to combine like terms, and then we're going to put our answer in standard form. Okay, so distribute each of the monomials, multiply the pair, combine like terms, put your answer in standard form. That's the biggest part that students forget at the end there, is that your answer needs to be in standard form. Let's take a look at using this distributive property. So we're going to take this negative 2x squared, and I want to multiply it to each of the terms. So we're going to multiply the coefficients and we're going to add the exponents. Again, multiply the coefficients, add the exponents. So we're going to take negative 2 times 3. Negative 2 times 3 is negative 6. Then we're going to add our exponents. 2 plus 2 is going to give us 4. For our next part, multiplying the exponents, negative 2 times negative 7. That's going to give us a positive 14. Excuse me, I misspoke. We're multiplying the coefficients. Now we're going to add the exponents. Now remember, if there's no exponent, that's the same as the exponent being 1. Okay, so we still need to add that in. So here we're going to have 2 plus 1 is going to give us 3. Next, negative 2 times 10 is a negative 20. And then we want to make sure we keep that x squared with it. Okay, we want to make sure we keep that x squared with it. So this right here would be your final answer. It already is in standard form. My exponents are going in descending order, so I don't really have to worry about that. All right, next, let's take a look at this one. So 5a squared times a negative 4a squared. So I'm going to multiply out my exponents. 5 times a negative 4 is a negative 20. Then a squared times a squared, we're going to add those exponents, and that's going to give us a to the 4th. Next, 5a squared plus 2a squared. 5 times 2 is 10. And remember, there's a little a to the 1st there. So a squared times a to the 1st, you're going to add those exponents, and it's going to give you a to the 3rd. 5a squared minus 7, so 5 times a negative 7 is a negative 35, and we want to make sure we keep that a squared with it as well. Check, our answer is in standard form, our exponents are going in descending order, so that right there is our final answer for that one. Let's take a look at number 3. So for number 3, we want to take 6y and distribute it in. So we're going to take 6y and multiply it by each of those terms. 6 times 4 is 24. Y to the 1st times y squared. We're going to add those exponents and give it y cubed. The biggest thing is that you know if there's no exponent, the exponent is 1. A lot of students think it's 0, but it's actually 1. So 6 times a negative 9 is a negative 54. And then y times y to the 1st times y to the 1st is y squared. 6 times a negative 7 is a negative 42. And again, you want to make sure you take that y along with it. So that right there is your final answer. Okay, I want you guys to go ahead and try and use the distributive property on number 4. Okay, so let's take a look at this simplifying expressions. So the first thing you want to do is to distribute the monomial to each polynomial in the term. That's what we just talked about just a second ago. We talked about distributing that in, and that's what we just worked on. So then you're going to multiply everything multiply the coefficients, add the exponents. Then you want to combine any like terms that are left over. So now we're going to start having like terms that need to be combined. Remember, like terms, the letters have the same exponents. And last but not least, our answer needs to be in standard form. So next, let's start by taking a look at number 5. So we're going to take that 4 and distribute it in, and we're going to take that negative d, or opposite of d, and distribute it in. So 4 times 3 is going to be a 12, and we're just going to keep our d squared there. 4 times 5 is going to be a 20, and then we're just going to have d. So now we're going to take everything in this second parenthesis, and that's just going to be multiplied by the negative d. Okay, so it's going to change the sign, and the exponent on the d should go up. So d times d squared, since it's negative, that's going to become a negative d cubed. Then we have a negative 7 times a negative 1 is going to become a positive 7. D times d is going to be d squared. And then we have d times 12, or negative d, and that's going to be a negative 12d. So now we need to combine like terms. That's kind of like we did on our first note sheet and our fourth note sheet. So I see that my highest exponent is d cubed. So I'm going to write negative d cubed out first. So once I've taken care of that, now I'm going to look at my d squared. So I have 12d squared plus 7d squared, and that's going to give me 19d squared. And then I have 20d minus 12d, and that's going to give me a negative 8, or positive 8d for that one. Okay, so that right there is your final answer. Okay, so let's go ahead and let's take a look at number 6. Oops, wrong way. Oh, stop. Just trying to create some space here. What's a woman got to do, right? Okay, so let's go ahead and let's distribute this in. So we have 3, and we're distributing that in. So 3 times 5 is 10. Or sorry, is 15. So 3 times 5 is 15, and then we're going to keep the x squared. 3 times 2 is 6x. 3 times a negative 4 is negative 12. So now here we're going to take and we're going to distribute in a negative x to each of those terms. So then I'm going to have negative x times 7 is going to be a negative 7x cubed. Negative x plus 2x is going to be a negative 2x squared. I'm going down to the next line to save some room here. And a negative x times a negative 3, that's going to become a positive, and you get 3x. So now I need to combine my like terms. So I have a negative 7x cubed here. Cancel that out. Then I'm going to combine my x squareds. I have 15x squared minus 2x squared. That's going to give me 13x squared. Then 6x plus 3x is going to give me 9x. And then I have minus 12. So that right there is your final answer for that one. Let's take a look at number 7. So for number 7, we're going to take this 3 and we're going to distribute it in. 3 times 2 is 6t squared. 3 times a negative 4 is a negative 12t. 3 times a negative 15 is going to be a negative 45. Now this 6t is being distributed in. Notice that we're just distributing it into the parentheses that follow. 6 times 5 is going to give us 30. T times t is going to give us t squared. 6t times 2 is going to be 12t. So now we want to take and combine our like terms. So we have 6t squared plus 30t squared. That's going to give us 36t squared. Negative 12t plus 12t, well, those are actually just going to cancel out. So I don't even have a t term. And then last but not least, I'm going to have this minus 45 left over. So that's your answer for number 7. I want you guys to go ahead and try number 8 on your own. All right, let's take a look at number 9. So Greg pays a fee of $20 per month for local calls. Long distance calls are 6 cents per minute, and in-state and local calls are 5 cents per minute for out-of-state calls. Suppose Greg makes 300 minutes of long-distance phone calls in January, and M of those are in-state calls. So now we know how to write an expression for his bill. So his bill is going to be something. Okay, so I know that when he starts out the month, he's paying $20 for just the local calls. No matter how many local calls he makes, he has to pay $20. So we know that M minutes are in-state calls. And for the price of those, it's 5 cents. Okay, then we want to figure out the long distance calls. Okay, so then it's 6 cents for in-state calls. And then it's 5 cents for out-of-state calls. So we're going to take the number of minutes we have, so it's 300 total minutes. Okay, so the number of out-of-state calls is going to take 300 minus our number of in-state calls, because your phone calls are either out-of-state or they're in-state. So if we have 300 total, and we're going to subtract off the number that was in-state, and that's going to cost us 5 cents. So now we want to simplify this expression. So I have 20 plus 0.6m. Now I want to take this 0.05 and distribute it. So 300 times 0.05 is 15. Then 0.05 times a negative m is a negative 0.05 m. So now I need to combine like terms. 0.06 m minus 0.05 m is just going to be 0.01 m for our bill, and then 20 plus 15 is 35. So what does this tell us? Let's say we know that Greg is going to do a total of 20 minutes in state. Okay, so that means we can plug in 20 for M, and it'll give us our total bill, including what we did for out of state, even though we don't know what that is. So that's what that expression represents. I want you to see if you guys can use a similar process for number 10 when talking about that parking garage. So I want you to go ahead and try number 10 on your own. Make sure you remember to take that Schoology quiz once you're done.